So as some of you might have noticed, there was some technical issues in the very beginning of the talk. This frequently happens. This is why you always have a plan B. I was planning on talking about plan Bs later in my talk, but this is why, even though I'm doing it on an iPad that I can write on, I also brought my laptop just so I would have two different ways of trying to interface. And so it wasn't interfacing with the iPad, not a problem. I am actually zooming from the iPad to the laptop, which is now projecting on the screen. And so there we go. The shirt I'm wearing is actually designed to emphasize Plan B. And I talked to my students about this earlier today. Are there any hockey fans here? Do you know about the emergency goalie rule in hockey? What is the emergency goalie rule?
If the main goalie and the assistant goalie both get injured, there's a guy who puts in the stand.
Yes.
And like you told me one time it happened, he came on and he won the game.
Yes. And so you don't have that many goalies on a team. And so there's always somebody in the stands who could come in at a moment's notice and play for either team. And so there was a game between Toronto and Carolina, and the Zamboni driver, who occasionally did practice for the Toronto team, actually came in, let up 2 goals quickly because I think he was nervous, but then settled down, had a great game in the net, and won. And so I actually bought his shirt, which helps his charity, as just a great emphasis of always have a plan B. And while I was waiting to talk about this later in the talk, given the technical issues, it's not bad to talk about this now. So my email address is listed on the top. If you can't find my email address in the 21st century between the web and your counselors, there are many other programs you can go to other than this one. Okay, and yes, I know this is being recorded. So I was given the following at a math camp that I was at in New Jersey recently. So you have the cards with the letters E, K, 4, and 7, the Wasson 4-card task. Which cards must you turn over to verify the rule that if a card shows a vowel on one face, then it has an even number on the other? I'm going to assume everybody knows the vowels here are A, E, I, O, and U, sometimes Y, not today. And the even numbers end with 0, 2, 4, 6, 8. So I'll give everybody just 30 seconds to think, which of these cards do you have to turn over to verify the rule that if a card shows a vowel on one face, then it has an even number on the other. Don't say anything out loud. Just think quietly to yourself. All right. You're confident you're going to get this right. Are you willing to bet your friend's life on it? Okay. Who's willing to bet their friend's life on this? All right. I think I saw your hand up first. Who's your friend? Okay. All right. Let's go for it.
E and 7.
E and 7.
Did I say something else?
Nope. Do you like this? Do you agree with his answer, or do you want to change it? How many people agree with E and 7? Okay, why E and 7? Yeah, I mean, your life's on the line.
Oh, yeah.
This is why I brought 3 students. They're masters at hiding bodies. Did you hear about the student who went missing last week? Exactly.
So this part is, if the card shows a vowel on one face, then it has an even number on another. So we should check the cards that are currently showing an even number, a vowel.
Okay, so you agree we have to check E. Everybody agrees on E. Is there anybody here who disagrees on showing E? Okay, everybody agrees on E. Okay. And now why'd you choose 7?
7 also shows a sign of positive. So
Okay.
One side is not even, but the other side should not be a vowel.
Okay.
Not even.
Does everyone agree with that logic? Does everybody agree that we should turn over 7? Does anybody have any issues with this? Yes. You should check K as well. You have made an implicit assumption. Actually, not you. Your friend made an implicit assumption. Actually, wait, we don't know that he is your friend. We just know that we just know it goes that way, right? So it's really your bad. You made an assumption. What was the assumption you made? What is the implicit secret assumption? Yes.
That every card had a letter on one side and a number on the other.
So nothing here says that every card has a letter on one side and a vowel on another. Most formulations of this problem say every card has a letter on one side and a vowel on another. When I was at the math camp, they actually did not have the standard phrasing, which I loved. Makes it a much better question. It is very easy to accidentally assume something. So if you get nothing else from the talk today, That's really shame on me, and it's probably going to not result in me ever getting to 17 talks at Hampshire. But at least get how easy it is to implicitly assume something that's not there. And so when we get to stuff later, I will apologize. I'm going to be very explicit because I want to make sure we're all on the same page. So we're going to play the pirate riddle, where we might lose a few more students. We're already down one so far. It's all right. We never said when. So is like 100 years from now good for you? 100? Okay. So write that down. So here is the pirate riddle. We have 5 pirates with the boring names of 1, 2, 3, 4, and 5. Okay? Has anybody seen this riddle? If you've seen this riddle, you are now mute. Do you know what mute means? Good, exactly. You didn't answer out loud. Thank you, right? If you're mute, you cannot talk. So if you've seen this before, you can't talk in the initial stage. So they must split 100 gold coins. The lowest named pirate alive proposes a division. If 50, oh, I forgot to fix this. If 50% or more vote for the plan, it passes and it's done. If more than 50% vote against the plan, it fails. And the proposer walks the plank and dies, and the lowest named surviving pirate proposes a plan. You repeat until a plan is accepted. We will assume all the pirates are intelligent. Okay, mathematician. Okay. Anybody do number theory here? So they study the rate of growth of this function, which makes them pirates. They study the rate of growth of this function, which makes them pirates. All right. So the pirates are intelligent. What is the final division? Okay. So I will give you all a minute or two to just talk amongst yourselves. What do you think the division will be? What kind of strategy? How would you attack this problem? Even if you don't know what the answer is, what might you do to build intuition? Okay. So think for a minute or two. If you want to talk to some of your neighbors. Or is there some information that you want to know before we start talking?
Yeah.
Oh, what's your question? Excellent. You can't analyze this until you know how the pirates vote. How many people think they know how the pirates vote? It'll be interesting to see if you all have the same thought. Years ago at Williams College, we basically gave the Are You Breathing Award to the student who went to the most colloquia. And so some parents told their kids, I know you're not going to win the prize for top math student, but you can physically sit in a seat. You can win this one. And then you have to go to at least 21 talks to graduate as a math major. Your talk counts as one. And then we decided to make it a little bit easier. We would allow students to go to up to 5 talks as a junior and have that count. And then we voted on this as a department. It passed. And then I raised my hand and said, I know this is probably a stupid question, but do those 5 talks count towards the award for the senior who has attended the most colloquia? And I was absolutely correct. It was completely obvious which way it goes. It was obvious to half the department that of course it counts, and it was obvious to the other half of the department that of course it doesn't count. Is it the senior who goes to the most talks as a senior, or the senior who's gone to the most talks possible? And so because it wasn't clear, we had 2 very different views. Somebody give me a thought about how they think the pirates vote.
If they can, if there's a way that they'll get more money if they.
No. How is the voting done? How do they physically vote? Yes. Yeah, it's not does. Give me how you think they vote. No. It's the mechanics of voting. How do the mechanics happen? Yes. They raise the hand. When do they raise their hand? Does pirate 1 go, then 2 go? And once you raise your hand, are you fixed to that? Treat me like a child. I would say like a graduate of a certain school, but since someone from that school might be here, yes. When? Do they raise it one at a time? Do they all raise it at once? Can you raise your hand and then lower it? Treat me like a moron. Yes.
At the same time and they can't see.
Good. So it's 1, 2, 3, vote, and it's a public vote. Okay.
No, I'm just raising.
Okay, you're raising your hand. Okay. Yes.
It's also unclear whether the pirate who proposed the division gets to vote for it.
The pirate who proposes gets to vote. So if there's 4 people, if 2 vote for the plan, it passes. If there's 5 people and 2 vote for the plan, it fails. Okay, so one thing is they raise their hand, and then that means everybody gets to see how everybody has voted. What's another way you could vote? Yes. Well, but so I guess you could do something like that. We don't say over here who gets to vote, so I will add that everybody gets to vote. Good. So that's another way to vote, is it's a secret ballot, and then you just know at the end if the plan passed, and you don't know who voted for or against it. And that could become useful as some pirates are dying to know how people voted. Another possibility is you could raise your hand and people could say, is everybody happy or does anybody want to change their vote? And then it's not done until everybody says final. So very similar to the EK47, until we specify how the voting happens, you could have different analyses of the problem. So let's do it, everybody votes at the same time, and let's do it by secret ballot. So you write down how you vote. So what this means is, as you're having your discussion, trust me, I'm going to support you. And then you vote by secret ballot, and then it's not known, potentially, if you stab them in the back. Now, if there's only one vote in favor and everybody else voted against, then anybody who said that they were going to support them, it's clear they lied. But if it's a secret ballot, you may not know if somebody stabbed someone else in the back. All right, so we will do secret ballot. And so think for a minute or two, how would you analyze this problem? How would you try to figure out what strategy to use? And so we're going to give everybody a minute to think. Oh, I'm sorry?
Still another part of making a decision.
I mean, the way it's done is you propose, the first pirate is going to propose a plan. And if the plan gets at least 3 votes, it passes and that division happens. If it fails, pirate 1 is killed and then pirate 2 proposes. If that plan is accepted, then that division is done. If not, pirate 2 is killed and then 3 proposes. So we're going to give everybody just a minute to quickly think about this. It's a shame I had some of my students who were performing today and they were singing either God Save the King or My Country 'Tis of Thee, depending on how you want to interpret the tune. Jeopardy music would have been great right now. So think about how you would attack this problem. And somebody who hasn't spoken, anybody want to, if you haven't spoken, anybody who hasn't spoken who wants to make a proposal. Okay.
It's just a question, but
Yes.
do the pirates want the most money for themselves or?
Good. So you need to figure out what is the objective. And I'm not going to answer that question right now. Does anybody want to make a proposal for strategy? Have you spoken yet? Yes.
Why wouldn't all the first few pirates just vote, like, why wouldn't all of the pirates just vote against the first few so that they can get the votes?
Okay. So one possibility is that, you might just say, I'll vote against you. So a couple of questions. Is the game clear? Are we at the point now where we understand what's going on? Yes. There was more than one way to interpret it. I think we're past that. Next, let's talk about how should you try to analyze the game. Anybody have any thoughts about how we should try to analyze? Yes.
I think you assume the pirates vote based on they want the most money, but also they want to live. And then you do casework on what 3 decides.
Why 3?
Okay, so let's say they all pull off 5. Wait, no, they kill off 1. And then.
So you're making it too complicated for what you're trying to do. Yes. Good. So we'll talk about that more in a second. Start from the back. whenever anybody gives you a problem, you always want to ask, why did they choose these numbers? Why did I choose 100? Why did I choose 5? Is there a simpler problem I can look at? This is a talk after dinner. So I do not want to talk with long math. Well, I do, but I'm not going to give a long talk with huge math equations. I want to try to do talks with ideas, ways to think about problems. So for this, the key idea is start with the easier problem and try to build up from that. Have you ever seen anything like this before? If you have, that gives you an idea of how to analyze. And we will see later today that there is something that most of you, I think, have seen that is somewhat similar to this. And as I said, what's special about 5 and 100? Are there anything special about them? So again, we now know the rules, and this should be if more than 50%. Okay, and so the suggestion was play a smaller game. Do not feel embarrassed about starting with an easier game. Can someone give me an easier game than 5 pirates and 100 coins? No. Yes. Yes. Right? 1 pirate game. What's the proposal? Yeah. I think we all agree that in a 1 pirate game, the pirate will win and get everything. If you want to make things a little bit easier, I will say that 1 pirate is meaningful. And just slowly add up things, okay? Building on our massive success with 1 pirate, now what game do we play? We said it before a moment ago. Yes, the 2. How many votes does 4 need for their plan? 1 vote. What should 4 propose? Okay, how many people want to be pirate 5 right now? Okay, thank you. So pirate 5, how do you feel about this plan?
I get to live.
You do get to live, but no matter what, pirate 5 always lives. Do you like this plan where you get nothing?
Not great.
Would you like to get some money?
Yeah.
Will you vote for or against?
I'll vote against.
Pirate 4, do you want all the money or would you like to die? Yeah. You're not going to get more of a softball question than this in life. Right? This is, if you've seen My Cousin Vinny, right? Do we all agree that pirate 4 is going to vote for this plan? Yeah. Okay. We're on a roll now. What should we do now? Pirate 4. So 3 has to propose. How many votes does 3 need? 2. No, 50% wins. But again, we have an odd number, so it doesn't really matter if it's 50% or more than 50%. Do you want to give me a proposal?
3 gives 5 1 point to 14 because if we get like killed, then I get killed. So and 1 is more than 0, right?
Yes.
Correct.
Okay, so people prove that 1 is greater than 0. 1 is the successor of 0. Do you all agree that 1 is greater than 0? If anybody does not feel that way, you're welcome to give me $1 later today. And you can do that as many times as you want. All right, so 3 is going to give 5 1. How much is 3 going to give 4? 0. And how much is 3 going to take for 7? Do you think 3 is going to vote for this plan? What would happen if this plan failed? 3 dies. 3 is a yes vote. And what was the argument 3 gave to 5? Yes.
If 3 dies, then 4 is going to take all the land. So 1 is greater than 0. So 5 1.
But it has some nice math in it because these are math pirates. So it has, an inequality, which is great. If you don't vote for my plan, you get nothing. So do you think you're going to get 5's vote? Do you think you're going to get 4's vote? No. And now note 2 is greater than 1/2 times 3. So passes.
Guys, if you want to get the vote, I promise you will be able to do that.
Wait, okay, so this is a really good suggestion. And what is 4's professional? So 4 is saying, if you vote against this plan, I'll split it with you 50-50. I'm sorry, I'm old. I've been here so many years, I can't remember things. What is 4's profession again? That's right. So 5, please trust me on my honor as a pirate. If you vote against 3, I'll remember this and I'll split it with you 50-50.
They're pirates, why are they perfect magicians? Pirates are not typically perfect magicians.
There's been some issues in academia. A lot of people, tenure is not what it used to be. A lot of people, you take the work you can get, okay? Could be internet pirates. Do you think 4 can convince 5 to vote against this plan? Is there any reason 5 is going to trust 4? No. You have no interest in adhering to the pledge you make to me. As soon as 3 is dead, I know you can take everything. What do you think would happen if there's 4 pirates? Remember, these are smart mathematical pirates. What do you think 2 is going to propose? Yes. Okay, and what's the proposal going to be?
That means 2 could offer 4.
And how much does 2 keep for themselves? And if you're 4, are you happy about this? Yes, because what happens if this plan fails? You get nothing. So we're going to get a yes, a yes. We're going to get 2 no's. It passes. And then if we have 5 pirates, what do you think the proposal is going to be if we have 5 pirates?
Number 1, I think number 1, it would like shave off like a little couple atoms of like so.
Good. So be specific now.
So if I would take like 99.
No,
98, 1, 1.
Good. This is, we're not going to be doing fractions. Nice integer. Do you think 3 and 5 are going to approve this plan? Yeah, because what happens if this plan is not approved? So what do you notice is forming? What's happening? What do you see? What kind of pattern are you noticing as we increase the number of pirates? What kind of alliances are forming? Yes. Yeah, the odd numbers and the even numbers. So the way this is structured, this is definitely leading you to the situation where there is a huge alliance among all the evens and all the odds. Because as soon as the lowest ranked person dies, the other party now gets to make the proposal. And so you know that if your proposal has failed, the other party could come against you. And again, in this situation, when we have 5 pirates, pirate 1 could try to win the votes of 2 and 4. 2 almost surely is not going to get anything. Could you win pirate 4's vote? How could you win pirate 4 vote if you were pirate 1? Yeah. I don't think you've said anything yet.
You give pirates 2 coins.
So if you give pirate 4 2 coins, you'll get their vote, but will you have enough votes now? No. So how could you win with pirate 4? What could one do? You could take 98 for yourself and give how many to 4?
2
coins to win the vote.
But then you're gonna have, then 98 and 2 is not gonna be enough. You have to get to 3 votes. How much should you give 4?
Wouldn't you have to give it to other pirates as well?
You would have to give it to other pirates as well. So give me a proposal that could also work. So you could give 1 to 4, and what else could you do?
1 to 3.
1 to 3, 0, 0, and 98. Or you could do 98, 0, 0, 1, 1. Would these green ones pass? Yes.
So if the pirate gets the same amount regardless of if they choose yes or no, do they like seeing the other pirates die?
That is a great question. And so if the plan fails, Pirate 4 can watch you die and then still get the same. And so what do you think? Does Pirate 1 want to make this proposal? Or do you want to stay with the odds? Yeah.
I think probably because like they don't know what Pirate 4 is gonna do if they wanna see them die. So it's like better not to take the risk.
I think it's risky to do this. So let's do a 3 pirate game. I'm not going to choose random pirates. I'm going to choose 2 people who have already been at play. I'm going to have you as Pirate 3. I'm going to have you as Pirate 4. Okay?
I'm dead.
Not yet. We said in 100 years. We never said when we were going to kill you. All right? So right now you are alive. Pirate 3, what proposal would you like to make? Okay, so say it out loud. Yeah, same rules. 99 coins. And how much for your friend? Okay. And how much for me? 1. Okay, do you like your proposal? Okay. Do you like the proposal? And now it's my turn. And now I come to you and say, you know, I do get more if I vote for this proposal than if I vote no. But I'm not getting as much as you. And if I vote no, what happens to you? And this is the comment that was made earlier. So this is now where we leave the real pirates and enter the real world. This is now negotiations. And a lot of it is, are you bluffing or are you serious? And we're just discussing things right now. I don't think this is a fair proposal. I'd like to make you a counteroffer that I would like you to consider. So here is my counteroffer to you. And I will use purple for Williams. You get 0. Pirate 4 gets 0. And I get 100.
Consider it, but probably not.
Okay, and so what will happen to you? You'll die. And I won't get anything.
That's fine.
Wait. No.
You know, this would you accept this offer? Or would you make me a counteroffer? And so what counteroffer? Don't say it out loud. Everybody think for a minute as to what do you think the natural counteroffer he should make to me right now. Don't say it out loud. Just think for half a minute. What do you think the natural counteroffer should be? Right? And then we'll have somebody else say it out loud. All right, all right, I think I saw some head shakes over here. Do one of you want to say a counteroffer? Okay.
80-20.
Which way? My counteroffer to you, don't toy with me. So this is a good question. And now it comes down to, how many times are you voting? And so right now we could say, we're not actually doing the voting right now. We're just discussing. And then we're going to put our stuff in. So we haven't called to vote yet. We're just discussing. Yes.
4 likes this plan because after that, 3 dies and then 4 gets to begin the plan. So then 4 and 5 both vote.
Well, but if 4 and 5 vote for either one of these, 4 gets nothing. If 4 votes for either of these plans, 4 gets nothing. 4 is not going to vote for this. I'm sorry? Yep. So, yes, what would you counter with? Okay, so what's your proposal? No, give me your proposal to piece 4. Go for it. So we don't know that. I mean, just because you killed 4 earlier, or give me a counter proposal quickly. I need, come on.
Probably a bad idea. I think. Yeah.
And I'm going to channel my inner 4. You know what? We've had our differences, but I think this is a good idea. And then what does 4 do? Vote against it in the secret ballot, right? Because if the plan fails, if you give 4 anything less than 100, 4 knows your plan is going to then, if it fails, then 4 gets everything. So would you do this? So what would be a good plan? What should 3 offer? Yes. So that's a great possibility. And I might counter with, if you had started with 50-50, I might have accepted that. But you started with 99-01 and you tried to screw me. So I'm still pissed. I'm not going to get greedy. I'm not going to be asking for 80. I'm not going to be asking for 100. I just want 1 more. Or you die. You guys ready? Where are the hefty bags? Okay. Excellent. Great. Okay. Yes. Was there a comment here or? Yeah.
If 3 gets to make the offer, then why should we consider 5s like counter offers?
Well, we're just discussing right now. You have to get 5's vote. And so it all comes down to, if I vote against your plan as 5, I get nothing. And so this is how negotiations go in the real world. If you are being hired as a consultant, do you want to say what you would work for, or do you want the other side to make an offer first? You want the other side to make the offer first. Let's say you're willing to work for $100 an hour and they offer you $150. Well, I normally charge $300. Or you could start and you could make the first offer. I'll do it for $50 an hour. Well, geez, we were going to give them $100 an hour and they're saying 50. We were thinking more like 25. So there's often a danger in first movement and whoever speaks first. And so in a situation like this, a lot of it comes down to, do you trust somebody when they say what they're going to do? How many of you know what MAD stands for in the Cold War? All right, yes. Mutually assured destruction. And the idea was each side in the Cold War had so many nuclear weapons that they could destroy the world. And so if you launch nuclear weapons on us, we launch on you, and the world is destroyed. No one can win the nuclear war. There is a great science fiction story, and the title gives away what happens, called Nuclear Springtime, where the Russians call up the US president saying, we want to discuss a way to resolve our differences. And the president goes, okay, and what's your suggestion? You will withdraw from NATO, you will bring all your troops home. Okay, and what will you give us in return? We will let you live. I'm sorry? We've just launched a nuclear strike on you. You're going to destroy the world? No, we calculated it very carefully. It's just below the threshold that will cause nuclear winter. Some crops will still grow. Now, if you happen to retaliate against us, yes, that will push us into nuclear winter and the whole world will die. Good day. And the Russians hang up the phone. And now you're the US president. The Russians have already launched. You can't convince them not to launch. Their missiles are airborne. You can't shoot them down. The whole premise of MAD is predicated on both sides believing that in this situation, the other side would launch. But when you actually get to that situation, would they really launch? Or would they say, damn it, they called our bluff. We're not willing to let the whole world be destroyed. They win. So if you can convince them that you would push the button, that's what you need to do. That's very different than what would you do in the actual situation. In these negotiations, does 5 have a huge amount of power? It depends how credible it's going to be a secret ballot. 3 can go back and say, look, I'm going to give you 1 gold coin and that's it. If you vote to kill me, I'm dead. You're going to end up with nothing. Would you rather have 1 or 0? And sometimes one might go, here's my vote, yes, I'm showing it to you, I'm putting it in the bag. Too late for me to change my vote. I voted as number 3. I voted yes. And so it's not clear what the negotiations would lead to. If you start off with 9901, you might actually piss off 5, and 5 might want more. If you start off with the proposal of 50-50, are you more likely to have 3 accept it? And you say, look, if our plan fails, 4 gets everything. I think the 2 of us should split everything fairly 50-50. Would you view that very differently than if the initial offer was 9901? And so as Pirate 5, I view it very differently. I find it very insulting that you wanted to take everything. I'm being nice. I'm only giving you a small penalty. I could have asked for a lot more. And so I don't know what the actual answer is. A lot of this depends on who's playing. And a lot of it is when you are negotiating, do you have the stones to make the bluff like this? And is it really a bluff? You have to be able to convince the other person on how to view things. So this is one of my favorite problems to do. It's not clear what the right answer is. If you just do the pure mathematics of working backwards, you very quickly come to the alliance of the odds and the evens. And you can try to see, could 5 maybe not be the person that's needed? Could we somehow have, Pirate 1 win over Pirate 4? But that's a risky strategy. Okay, so what I want to do now, this was just a website I found which had this riddle, which basically has this parity solution, which I do not think is correct. I think if you have a more interesting set of pirates who have some psychology knowledge and are willing to bluff, you're going to get very different answers. All right. How many of you have seen the Towers of Hanoi? So this is a problem that I thought most of you would have seen. So the way it works is you have 3 towers and you have a bunch of rings. And the rule is you can never have a ring on top of a ring that is smaller than it. And the goal, for some strange reason, is you want to move all the rings from one tower to another. Does anybody ever explain why we want to do this? Does anybody know why we want to move them from one tower to another? Yes, is there a reason? I love it. Beautiful. Okay. So in order for the chicken to cross the road, there can't be a tower of pegs in the way, and so we have to move them off this one to one of the other ones. It doesn't matter, but this will open up this road for crossing. Love it. Okay. And so the question is, what is the best way to do this? And this is another problem where the standard way of solving it is you first solve it when you have 1 ring, then 2 rings, then 3 rings. You work backwards. This is very similar to the pirate riddle. You start with an easier version of the problem. If I have just 1 ring, it's not that hard to move it to another tower. 1 move. If I have 2 rings, I move 1 ring to 1 tower, the next ring to the next tower, and then I move the first one to that one. So that would take how many moves? 3. If I have 3 rings, I went online, it said it takes 7 moves. If I have 4 rings, it takes 15. If I have 5 rings, it takes 31. If I have 6, it takes 63. So the numbers are 1, 3, 7, 31, and 63. Does anybody recognize these numbers? Yes, in the back. They are 2 to the n minus 1. Are you absolutely certain that that is what it is?
Wait, you said for 1, it's 1. So, yeah, I think so. I mean, I'm not absolutely certain.
Okay, so you're not going to bet anybody's life. Okay. So there's a great problem about how many, if you have n lines, what's the maximum number of segments or regions of a circle can you get? And it starts off looking like something that we can. And so there's a wonderful website called the Online Encyclopedia of Integer Sequences. Oh, and it seems like things have slightly reformatted as I'm displaying it. So let's see if I can. I'll do it this way. All right. So the Online Encyclopedia of Integer Sequences, you can punch into this website a sequence of integers, and it will tell you all the places it can find it If there are formulas, it will tell you what the formulas are. It will give you references. It's an absolutely wonderful site. So when I plugged this in, it said that there were 24 sequences that began this way. And the first one is 2 to the n minus 1, exactly as you said. But there are other sites, other sequences that work. One is Mersenne numbers for which the product of the digits is not 0. I really doubt whatever Mersenne numbers are that they're the ones that are coming here. There's the length of the nth Zim word. There's lots of different things it can be. But this gives you an idea of what to try to prove. And a lot of times in mathematics, just having an idea of what you want to prove is extremely useful in then doing the calculations. And so the more data you can get in the beginning, the more likely you are to narrow this down to just 1 or 2 things. And then they will often tell you how these arise, and that will give you an idea of how to prove things. So I've actually proven some things in some number theory papers I've written where we got the inspiration of what to try to prove by punching the sequence into the encyclopedia. Okay, so what I want to do is I got a couple of minutes left. I want to try to end with some possible research projects. So in case anybody here is interested in trying to hand at some math research, how do you do math research? One thing is you learn how to ask the same standard questions to almost any talk. If I remove this condition, is this still true? What happens in higher dimensions? Can you give me some generalizations of the Tower of Hanoi? I've got some on the next few pages. I don't want to go straight to that. What would you think might be a generalization we could look at? Yes. More towers, right? What else? Yes. More pegs. So more pegs we've kind of already done. So we know that it's 2 to the n, 1 less than 2 to the n. What else? Good. Different height rules. Anybody want to give me a possible height rule?
I don't know, something like, I don't know. Table like, you would define it a way like, you take 2 off the top, and then you're doing like 6, you take the next 2, and you like do it like that. Or like, there's like some weird like switching moves you can do out.
Okay, so that kind of height rule, you might not actually be able to get to a solution.
Yeah, no, I know. I'm just saying.
Right, but no, it's fine. And it might be that as I choose the rules, it might get to a game that doesn't have a solution. How many of you know Conway's Game of Life? So you spend a lot of time trying to find what would be a good set of rules for the game that would lead to interesting behavior. So there's, I think, good ways to make different heights work. And so I'll leave that for now. Other thoughts?
It's like, or if you like start with multiple stacks of like things with the same size.
Good, so you could have multiple stacks. Let's do one more. Any other thought? Yes.
Not to put like smaller ones up on the bigger one.
Completely remove it?
Okay, wait.
No, again, that's perfect. You start off with something, and if it becomes too trivial, then you make it less trivial. Remove weight condition. So what's a weaker version of that, maybe?
The smaller one doesn't necessarily have to be on top of the bigger one, but their sizes have to be within a certain number each other.
Good. So all of a sudden, yes.
What if you number all the disks in equal size and decide that their number mod 3 corresponds to whether they're made of, mod 4.
Good.
Whether they're made of ice, iron, sodium, or some other metal. And obviously you can't use ice and sodium.
Oh, good. Wonderful. Cannot have certain residues touch. Like we might not want to have a Williams student and an Amherst student adjacent to each other, right? Out of curiosity, did we come in the same car? No, exactly. You're gonna spend 90 minutes in a car with someone from Amherst? No, we took 2 cars. I don't want to take my car to the cleaner. There is a reason, she's visiting some of her friends afterwards. Otherwise, we would of course been happy to ride together. But no, this is a great condition. Now all of a sudden you can be next to something. Yes.
Like, what if each move, you were only allowed to move, like a certain amount away, and that changed every move? Or maybe cycle back.
So what I hope you're seeing is it's not hard to generate questions. The question is which of these can be answered, right? But so what is it? So some of the ones I wrote down is more towers. Maybe you can support any disk that is less and any that is the next heaviest but not too heavier. Or maybe you can support something that's up to T times the weight above. And so maybe I could have multiple disks above me, but the weight can't be maybe more than twice my weight when you add up, or 3 times my weight, or 5 times, something like that. There's lots of conditions you can put in. Using phenomenal graphics capabilities, what if you can only move to an adjacent tower? Okay, and I will draw the towers of Hanoi, the original one, as an equilateral triangle. I am sorry that I do not have a 17 gone here, but if you count the number of dots, it's 17. I have absolutely no idea if that's true. But I see some of you are now counting quickly to say, is it 17? Yeah, it's 17. Oh. Isn't that 17? If you look here, isn't that 17? Right? With enough ways to draw the line, I can get a 17. Come on, this isn't hard. So maybe you can move, but you can only move to an adjacent tower. And so if I draw an equilateral triangle, then I can move from any tower to any other. I could draw a square 2 different ways, with or without the connecting diagonals. And then you could ask, what would and now we're actually trying to play the towers of Hanoi on a graph, where it now matters which vertices are connected. So then I did a larger grid over here. Where would you want to put the initial points? How many people would choose the center? Not everybody. How many places are there to choose where to put the initial? Yes. Yes. Good, it's like playing tic-tac-toe. Up to symmetry, there are 3 opening moves. You can put everything in the center, you can put everything in a corner, or you could put everything in one of the middles. And so you could then say, what would the solution be depending on where you put it? And maybe there's different games you could ask, I want it to be moved to another one. What about the last picture? What is the last picture? So what is the last picture? Yes. Yes. So I was on academic probation at Yale. It wasn't my fault. And I had to quickly add 2 classes to my schedule. And I found out that I had to add these classes 2 weeks into the spring semester of my freshman year. So I was 2 weeks into the semester, so I had to be very careful what I added. One of the classes I added was baby logic. And I think the first midterm of the class, 50% of the exam was 10 questions. And they were like, P and Q implies not P or Q. There were 10 sentences like this. And the instructions were, state which of the following sentences are true or false. I'm a math major. I can answer all of these very easily. I answered them. I got 100 on the exam. I asked the professor afterwards, this is a logic theory class. You technically used the inclusive or. Every sentence is truth value determinable. The answer is yes. All of the sentences are true or false. She said, very funny. I would have flunked you, but very funny. So your question was, is this a cube or a hexagon? And the answer is yes. Depending on how you look at this, this is either I'm trying to draw a 3-dimensional cube and it's perfectly aligned and you are not seeing the dot in the far bottom, or it's a hexagon. And so this was done very deliberately. And this is why I actually have big, thick dots among things. So If I do it as a cube, I now have a three-dimensional problem. And so again, there's lots of ways to take things that you've seen and try to push them in new directions. And so if anybody's interested in looking at any problems like this, please, shoot me an email. There's an AI summary, which is on the slides about, some generalizations of the game. The first thing you would have to do is look to see if any of your generalizations, any of your questions have already been done. Feel free to shoot me an email at sjm1@williams.edu. Does anybody know what color I should have written this in? Purple. So I'll rewrite it in purple. Okay, so thank you.